Yesterday I made an assembly error, and today I fixed that and get the left hand side buttoned up. I was talking about a problem where this bottom cog here and that gear there was a slight difference in height of them, and that the dog that slid up and down here was hitting that other gear. I machined the edge off the dog to get clearance. I then still seem to have problems at the top of this shaft, and it was taller than this cog, and the bearing that went on here rubbed on the cog that goes on there. So there was a problem there that I'm thinking is related to the differences possibly in the crankcases. This morning when I started measuring heights of bearings and the depth of the cutouts in the cover, thinking, well, I don't need bearings fouling on the cover and things, I reinvestigated things, and this dog, which is what I machined, goes on this column and drops in down and engages there like that. But I also worked out that it also can go on and engage with the bottom like that. Turned it upside down. Now, the bottom of that is smaller than the top of it, so there's no need for a relief in the side of it. And these are smaller dogs, and the cutouts in the bottom of the top cog are small dogs, dog holes there if you like. And so the larger end of this wouldn't engage in that top gear, so the gear was actually sitting on top of this, and these weren't going into the dog holes if you like. Turn it over and these do go into the dog holes, then lowers this on the shaft and the problem disappears. So I have machined this unnecessarily. So fortunately I've got the spare one, which this one was out of the spare motor. I went back and grabbed the parts out of the 94. This is the original one. I've checked that it fits on this shaft and that it engages. It appears to be exactly the right part. The small dog's facing to the top. It's just a matter now of putting the cog on the top, and now this is lower than this cog here, giving clearance, so the bearing that goes on there fits and doesn't scrape on there, lowers it down, so all of these bearings I think will end up on the correct plane. There's actually a shim on there, and then the bearing, there's a shim on there, and then the bearing. Now this bearing was being held up because the cog wasn't right down, so the problem's compounded. Now these two bearings should be on the same plane because the depth of the cutout in the cover is the same, and this one over here is slightly higher, which it is, so that now matches the case properly. So there's a diagnosis of a problem that I caused myself through poor assembly, and I've solved it. I was thinking I was going to have to make up different size shims and frig around, like I had to modify that dog to thinking I was working with perhaps a different spec casing, which I haven't had to. So I'm relieved that I've worked that out and we can move forward. I'm making a new gasket for this quad bike. I bought an original, that's the orange one there, and that's an old piece of 0.8mm gasket paper that I had in the shed. And the first thing I did was trace around the actual cover on the grey paper, and then overlaid the actual gasket, because you get potential sort of shrinkages in the paper gasket that you buy for if you were just going to trace around the gasket itself. So I've traced around the gasket. I've laid the gasket out over the outside tracing that I made, and then sort of adjusted it where need be to trace the inside and describe the holes. But overall, I think I'll end up with a gasket that will fit as equally as good as the original. Now I'm going to put one of these aside. I'll probably not actually use the grey one, keep it as a template for the next time I need one, because I think each gasket was $30. So I've got enough of this grey paper to make both side covers. The new original gasket lying on the casting there, and then I've made a pattern of it that I'll keep on file for future use. It's the actual internal shape of the gasket which can't be traced, so I've drawn it out on this paper. I've cut out the outside, but I haven't punched any of the holes. As I said, it's really the internal shape that can't be traced off the cover itself. So in future, if I use this one, I'll make another one and always have one up my sleeve to save spending $30 on a replacement each time. Although it does take time, and if time was money, you'd spend the $30. I've got that gasket in place. I've got the dowels in place. That sits nicely over all of the holes. That's the stator in place. I've got the nut tightened up on the crankshaft, holding the rotor down. We call this the AC generator in the Suzuki book, so magneto in other people's language. I'll come back to you when I'm knocking it on. There's 13 bolts or 14 bolts around that crankcase, one in the middle and 13 around the perimeter. That's not counting these few that hold the recoil on. That's the crank rolling over. That's the back axle rolling, and you hear it running some of the stuff inside. I've just bolted a piece of wood across there using 4 of the recoil starter tapped holes to stabilise the motor when it's up the other way. I still need to find something to put under this end, but that'll be a good start up that end. Somebody was asking me, how does the freewheeling happen when, if you're riding down a hill, you should get engine braking happening? And the way that works is there's a Sprag clutch in the bottom here, so the drive between, you can see I'm spinning the cup there and the crankshaft's not turning. If I turn it the other way, the crankshaft does turn. This is the direction of rotation. You can see my dodgy timing chain and the conrod rocking up and down over there. So that's the normal direction of rotation. Now, the crankshaft, if I just turn the crankshaft in that same direction of rotation, I'm holding the cup there and the cup's not turning, only the Sprag clutch in the middle. Now, that was normal direction of rotation. It's clockwise on this end of the crankshaft. So the cup's not turning. What makes the cup turn? Well, the centrifugal clutch at high speed flies out and makes the cup turn with the crankshaft. And while I'm now turning that cup, the crankshaft's still turning because the Sprag clutch that's the direction it locks in. But if you haven't got the revs up and it's just idling, the crankshaft can turn in there, and you can see the cup's not turning. I don't know. Yes, you can see in that shot that the cup's not turning. So that's the crankshaft running in idle, and the centrifugal clutch is not engaged. If you're rolling down a hill and you want engine braking happening, the other clutch is effectively pushing the bike and driving this cog down here, which is part of the cup. You can see the oil pump down there is running off another cog. So this cog is attached to the cup, and so the cup's turning this direction and it's dragging the crankshaft along with it. So you effectively get engine braking. If I stop there and try and turn, it spins backwards, fine, but that's not what that you don't get it rolling backwards. It's your engine braking happens when you're rolling down a hill, and the way that clutch is this Sprag clutch is not as distinct from the centrifugal clutch is set up. Is the transmission will push the crankshaft around, and therefore you've got the resistance. You're not giving it any throttle, and the engine's basically gone back to an idle, and you're rolling down a hill. It tries to speed the engine up, and this will make the engine run faster but give you engine braking at the same time. So that's two types of clutches here. A Sprag clutch one way in the centre there, and then a centrifugal clutch around the outside, which once the crankshaft's spinning fast enough, the weights fly out into this cup and then drag the cup around with the crankshaft. So that's how a conventional centrifugal clutch works. The other clutch I'll do some videos on is more of a conventional clutch, which is operated when you press the gear shift. It runs on this gearbox, or that's the input shaft to the sequential gearbox here, and the drive from this gear to the larger gear on the clutch pack will spin freely if the gear shift is pressed in, and otherwise it is the drive from here to this shaft with the springs inside the clutch. It's normally engaged, only disengages in between gear shifts. So I don't know whether it's a long-winded explanation, and I might become clearer once I get more pieces in place, but you can't see this Sprag clutch once the centrifugal gear, which I haven't cleaned up yet, is in place. I've got very little pad showing past the metal, and I just dropped the washer past the metal on this. I don't know whether it's close to buggered. I don't know what a new one looks like. This cup has got a slight heat mark on it, and the centrifugal clutch and this basket on the 94 bike was a lot blacker, and there was even less material left on the centrifugal clutch. Well, time flies when you're having fun. Get out to your shed and do the same.